Welcome to the world where engineering meets intelligence. Myself, Dr. S. Praveen Chakravarti, Professor and Head, Department of Biomedical Engineering, Dr. NGP Institute of Technology, Coimbatore, Tamil Nadu. In today's session, we are diving deep into one of the most fundamental yet fascinating subjects in biomedical engineering, that is sensors and transducers. From heartbeat monitors to industrial automation, these tiny components play a giant role in connecting the physical world to the digital. Whether you are a GATE aspirant, a curious student, or a tech enthusiast, this video will give you clarity, concepts, and confidence. So let's begin and decode how our machines sense the world. Let's dive into Unit 1, Introduction to Measurements. Imagine this, your body is the most advanced sensor system ever created. From your eyes to your skins, ears to your fingertips, you are literally walking talking proof of a fully integrated biomedical sensor system. But wait, where do you see artificial sensors every day? The thermistor in your water heater, touch and proximity sensors in your smartphone, fall sensors in your smart helmet, SpO2 sensors in your smartwatch. These are just devices. These are life-saving tools. During COVID, who could forget the pulse oximeter on every bedside table? One tap, one reading, one life reassured. A small sensor can create a giant impact. Now let's go to hospital. Imagine an ICU without ECG electrodes, blood pressure cuffs, infusion pumps, ventilators. Without sensors, machines are blind. Without transducers, even AI is useless. Diagnosis becomes a guess and monitoring becomes a myth. Sensors are the eyes and ears of a modern medicine. Let's make things simple. A sensor detects the change in the environment, whereas a transducer converts one form of energy to another. For example, a thermometer senses heat and transforms into mercury height. A microphone senses sound and transforms it into electrical signals. In biomedical devices, a pacemaker senses pressure and converts it into an electrical pulse. So, in short, a transducer is the bridge between the real world and the machine world. Here is why this matters, why we should care. Mission 1, design sensors to detect cancer earlier. Mission 2, create implants that monitor infection in real time. Mission 3, build wearable tech that works even where no doctors are present. Think beyond the classroom. What if your t-shirt could monitor blood pressure? What if a single sensor could predict a heart attack 1 hour in advance? You are not just learning, you are preparing to build the future of healthcare. If you could implant one sensor in human body to improve health, and what would it measure and why? Please post it in comments. So for me, it's mental stress sensor, nutrition level detectors, sleep quality in brain waves, glucose monitors without needles, and a sensor to predict heart attack 1 hour in advance. So take it as an assignment. If you are an enthusiast, map each human sensor to a biomedical device and explain the analogy. Design a sensor based solution for a healthcare problem caused by the failure of any of these natural sensors. Create a poster or podcast explaining one human sensor and its modern biomedical application. So let's move on to the next segment. What is measurement? Let's define it now. Measurement is the process of comparing an unknown physical quantity with a known standard. Examples: measuring body temperature using a thermometer, measuring blood pressure using a spigometer. The key components of measurement systems include, yes, you are all aware, it is measurement, which is the physical quantity to be measured, and a signal conditioner. You use filters, amplifiers, or digitizers. You need display and storage so that you present the records of the data. So let's move on to the next segment. Examples of measurements in healthcare. In a hospital, measurements include body temperature, body blood pressure, heart rate, respiration rate, blood glucose, ECG signal. Each of these requires precise sensors, and their accuracy can literally mean life or a death. Imagine in an ICU, if the oxygen saturation reading is off by 5%, a patient may miss critical oxygen therapy. If an ECG sensor gives noisy data, it may lead to wrong diagnosis of arrhythmia. So, measurement errors is equivalent to delayed decisions, and patients may be at risk, which is why signal conditioning is key. It amplifies, filters, and prepares the signal for digital conversion. It's like a translator between the sensor and the processor. So you can have many types of measurements: direct measurement, like using a thermometer; indirect measurement, like calculating BP using cuff pressure. Indirect methods are often less invasive but require high accuracy and calibration. Next comes the systematic error, which is the repeatable, predictable. Example: calibration issues. There comes random errors, that is due to noise, patient movement, and interference. Gross errors, it's due to human mistakes. Example: misreading equipment. There are environmental errors. Those are caused by temperature, humidity, or magnetic fields. Understanding these helps improve safety and design better systems. Yes, there comes two terms we get often confused: accuracy versus precision. Accuracy is closeness to the true value, whereas precision is repeatability or consistency of results, even if it is going wrong. So I was shown a reading from a thermometer that is used in ICU. Trial 1, it measures 39.8 degrees centigrade. Trial 2, it measures 39.7 degrees centigrade. Trial 3, it measures 39.8 degrees centigrade. It's precise because readings are consistent, not accurate if the true value is 37 degree centigrade. So a thermometer may be precise but not accurate. In biomedical systems, you need both accuracy and precision. There are some AI tools wherein you can differentiate, calculate accuracy and precision. I have given for your knowledge: TensorFlow, scikit-learn, BioSpy, Neuro2, PyTorch, MLflow, FarML, IBM AI Fairness 360. When you can use MATLAB AI Toolbox and SciPy. So the reliability and the durability. span and full scale, threshold, zero stability, drift, resolution, and range defines the performance measures of sensors. So we have an analog nature, digital nature, pulse nature, and a canvas nature. So final takeaways. Sensors and transducers are nervous system of modern medicine. They are present in every ICU, wearable and diagnostic device. Understanding measurement, error types, and system components is the foundation of reliable biomedical innovation. Remember, a misread sensor can cost a life. A well designed one can save thousands. Thanks for watching. Please post reflective critics on the session and topic for more biomedical engineering lessons and get preparation tips. Please follow the channel. Drop your questions in the comment and don't forget, what sensor would you invent to improve global healthcare? Thank you.